Imagine a string of text capable of reaching into a highly secured facility and ripping heavy machinery apart from the inside. This code was engineered specifically for the physical annihilation of industrial hardware. In 2010, the global cybersecurity community uncovered a malware worm that achieved exactly that. They named it Stuxnet. By turning lines of programming into a kinetic weapon, that discovery permanently erased the boundary between digital space and real-world warfare. This satellite view shows the Natanz facility in Iran. In the mid-2000s, the country rapidly expanded its nuclear program at this massive, heavily fortified site. Inside, the facility operated thousands of centrifuges, tall, silver cylindrical machines like these, which spin at supersonic speeds to separate uranium isotopes. To protect these critical machines, the control network was air-gapped, physically severed from the global internet. No Wi-Fi, no Ethernet cables. This physical void made remote cyber attacks practically impossible. You cannot hack a system you cannot reach. This created a severe tactical dilemma. A traditional airstrike on the facility risked triggering a massive regional war, and hacking it from the outside was a technological dead end. Yet, without a single bomb dropping, the centrifuges at Natanz began to fail. Engineers watched their machines inexplicably shatter, completely unable to pinpoint a mechanical reason. The answer finally emerged when cybersecurity researchers isolated a hyper-sophisticated worm deep inside the facility's isolated servers. The attackers bypassed the heavily guarded air gap by hitching a ride on something mundane, an infected USB thumb drive. All it took was one unwitting employee physically plugging a drive like this into an internal computer. Once inside, the code spread silently, exploiting 4 distinct zero-day vulnerabilities, flaws unknown to the software's creators that are exceedingly rare and expensive to discover. The presence of multiple zero days meant this was a meticulously planned, heavily funded operation, engineered specifically to cross into isolated physical spaces. We can see the specific target of the worm right here. Stuxnet ignored standard desktop computers and hunted exclusively for these: Siemens programmable logic controllers, the exact hardware that commands physical valves and motors. The payload initiated a 3-step kill chain. First, it seized authority over the centrifuge motors. Second, it drastically altered the rotational speeds to overstress the cylinders. Finally, as the machines ripped themselves apart, the code fed perfectly normal safety data back to the monitors. Imagine sitting at these very consoles. The human operators looked at their screens and saw total stability, completely unaware that the physical machinery in the next room was systematically destroying itself. The immediate result was a massive tactical victory. Stuxnet ultimately destroyed roughly 1,000 centrifuges, delaying the Iranian nuclear timeline by years. No government has officially claimed responsibility for the attack. However, intelligence experts widely attribute the worm to a highly classified joint operation run by the United States and Israel. The motivation was purely pragmatic. They needed a way to cripple a dangerous weapons program quietly, avoiding the devastation of an outright military conflict. But while the mission was a success, it left a permanent mark on global security. Stuxnet proved that digital code can inflict severe, real-world structural damage. Because the blueprint for this attack is now out in the wild, the threat surface has expanded globally. Civilian power grids, water treatment plants, and automated factories are all built on the same vulnerable infrastructure.